Chapter 6, Section 3, Domain and Range, Apprentice video. This video is mainly to give you a background on different notations and how to write things. So let's talk about integers and sets. What are they? How do we write them, etc. So first of all, an integer, it's simply it's a whole number. So no decimals, no fractions. But it can be positive or negative. Okay, so 5 is an integer, 10 is an integer, negative 4 is an integer. They're whole numbers, but they could be positive or negative. Okay, so I have a bunch of numbers here. I want to circle all of the integers. Yes, 1.2, that's not an integer. That's not an integer. 0 is an integer. Yes, it is. That one is. No. This one is. You may think, oh, it's a fraction, but remember, 8 over 2, that's 4. Okay, so negative 4, that's certainly an integer. 12 is an integer. This is not. Okay, 15 over 2, that's 7.5 or 7.5. Definitely not an integer. Okay, so hopefully you're comfortable at least identifying what an integer is. Now, when we talk about integers in general, okay, we call it a set, meaning it's a group of numbers. Obviously, there are infinitely many. We actually have a symbol for them, and it's a capital Z, but it kind of has a bold double bar here. Okay. So if you see that special Z, it just means you're talking about all of the integers that exist in the universe. Now, if you are working through our particular textbook that we use, I don't know why, but they use the letter I. Well, they use it probably because I stands for integer, but in the world of mathematics, that letter is never ever used. So I don't know why they decided to reinvent the wheel, but there you have it. But in traditional mathematics, Z always represents integers. You're also going to start seeing this symbol here. Now look at it carefully. It's not an E, okay? It's rounded. That is actually that's a letter of the Greek alphabet. The name of the letter is epsilon. Okay, but in mathematics, when you see that symbol, it actually translates into English. Okay, it means is an element of. Okay, so as soon as you see this funny looking E, which is not an E, it's an epsilon, it just means in English is an element of. Okay, why do we use all these symbols? Well, in mathematics, if you want to say something quickly and efficiently, well, sometimes it's not always best to use long sentences. So we use symbols to make things, well, more easier to read. Okay, so all we want to do here is do some translating. So I have the number 4. 4 is an element of the set of integers. Okay, so that's a statement. Obviously, 4 is an integer. It's a positive whole number. So that's written in English. How do we write that using symbolic notation? Okay, well, 4 is an element of the set of integers. So using the notation, we would say 4 is an element of the set of integers because the Z represents integers. So this is like if you were wandering around with a big suitcase, and inside that suitcase was every single integer that existed in the entire universe. If you were to open and sift through that bag, the number 4 would be in that suitcase somewhere. Okay. Next, 6.8 is not an element of the set of integers. Yeah, that's definitely true because that is not a whole number. So how do we say this using notation? So we'd say 6.8. Well, that is an element of. So if we want to say is not, we just put a slash through it. Okay, it is not an element of the set of integers. Right, the third example, we're actually given the notation first, and we just want to translate it back into English. So this says 0.5 is not an element of the set of integers. So I'll just write that in English. So we have 0.5 is not an element. So you can see how writing it out in English might be a bit painful. That's why we use symbols. Is not an element of the set of integers. And once again, what's a set? It's just a collection of things, in this case numbers. So the set of integers is a collection of all of the integers in the universe. So there we go. All right, so moving on to real numbers and sets. Okay, now I'm actually jumping the gun a little bit because we talked about integers, but there's a type of number that we usually talk about before we get to the real number, so we'll just squeeze that in. Okay, and that is what's called a rational numbers. This is just some extra rational numbers. Okay, the symbol for a rational number typically in mathematics is a kind of a funny Q. Okay, so that's the symbol. All right, so what is a rational number? Well, a rational number is any number that can be written as a fraction of two integers. Okay, so obviously that does include integers because, say, the number 3, we can write that as 3 over 1. Okay, so basically any fraction of two integers, okay, is rational. Also, if you have a decimal, let's say it goes on forever, but it repeats somewhere. Okay, this can also be represented as a fraction. So all 3 of these numbers are examples of rational numbers. So what's a real number? Well, real numbers include integers. Okay, they include fractions, or rational numbers. But they also include numbers that are called irrational. So we have irrational numbers. What's an irrational number? Well, an irrational number is a number that does not fit into this category. So it's not an integer, but it also cannot be written as a fraction. Okay, so an example would be, say, of irrational. Let's say you have a decimal and you write a few ... So that just tells me that the number goes on forever and there's no discernible pattern. It doesn't repeat. So that would be an irrational number. You can also generate an irrational number, and you'll see this later on in the course. Suppose you try and take the square root of a number, but the number is not a perfect square. So let's say 17. If you put that in your calculator, you're going to get a nice, long, ugly decimal. Of course, it will stop because your calculator has no more room to fit numbers. Okay, but these are irrational numbers. So again, the real numbers include all of these together. So real numbers include the integers, the fractions, okay, so all the rational numbers, but it also includes irrational numbers. And irrational numbers, when you write them as decimals, you cannot write them in their entirety. Okay, they go on forever and they do not repeat. In this course, you will only deal with numbers that are real. Okay? The natural question is, okay, what's a number that's not real? You're not responsible for that in this course. Okay? If you want a little lesson on what a non-real number is, feel free to come and talk to me. So, circle all real numbers. Well, I did tell you that all the numbers that you come across in this course are real. So this is pretty simple to answer. Okay. You're not responsible for any numbers that are not real. But I'll throw in one that's not. Okay, I won't explain, but let's suppose you want to take the square root of a negative number. Negative 25. Well, you're going to run into trouble because the answer to that is not 5, nor is it negative 5. Well, what is it? Okay, there is an answer, but it is not a real number, and again, you are not responsible for this. All right, so let's talk about notation. The set of all real numbers is represented by, remember, the Q is rational numbers, the Z was integers. If you're talking about all real numbers, let's go back to blue here, we just use a capital R, and it's kind of bolded here on the side. Okay, so if you see capital R like this, that just means a person is walking around with a suitcase and it's full of all of the real numbers in the universe. Okay, all in that set. All right, so we say 4 is an element of the set of all real numbers. Okay, so we'd say 4 is an element. It's found in the collection of all real numbers. Okay, it's an integer, but remember the real numbers include integers as well. Okay, 6.8, remember that's not an integer, but it is an element of the set of all real numbers. So 6.8 is an element, or it's in the set of all reals. All right. And now let's just go the other way. We have -5 is an element of the set of real numbers. Okay. Well, all I did was I wrote 3 little symbols here, and it says basically all this stuff. Okay. So I'm making you translate it back into English so you can appreciate how handy it is to use symbols. All right. So we'd say -5 is an element of the set of all, I'm running out of room here, real numbers. You want to stick with writing it out in English, be my guest, but I don't recommend it. There we go.